Hello, everyone. Welcome to today's lectures. I'm Wei, and I'm very happy to be here to present these lectures. Today, we will learn how to write Pythons in a more advanced ways. But before we moving to today's lectures, and we will spend a little time to review what we have learned in the last lectures. First, we have learned how to use Python and NLTK to make some basic test analysis, and also we learned the concept of n-grams, and we know how to write a Python code in a more efficient ways compared to other programming languages. And please feel free to check the solutions of previous exercise, and also make sure you have read chapter 2.1 to 2.3 in the NLTK website. And also we have learned how to make cumulative distributions for words in a given corpus. And also we learned both frequent and infrequent words are not informative to test understanding, while the intersection between frequent words and the long words are more likely to be the candidates to know what the articles are saying. Also, we have learned the test analysis is very important for the daily life, because we can develop very cool NLP applications to help people to understand tests. For example, we have 3 different articles here, and they are talking about different things. So the first things we can do is develop NLP applications to label these articles into different categories. And also we can extract informative words from these articles, and to figure out what topics they are talking about. And also we can make some semantic analysis for these articles to see whether the opinions the author trying to express in these articles are positive or negative. Also, in the last lectures, we know lexical diversities, which is defined as relations between distinct words and the total number of words for a given corpus. Then we can use these measures to judge the language ability of speakers and writers. Also, we learn the concept of n-grams, such as unigram, bigram, and trigram. The difference between these grams is every word unit has a different length. For example, bigrams, where every word unit has a length of 2. And usually we can use bigram to speak for collocations, which is a sequence of words that occur very often together. For example, people prefer to say strong T instead of powerful T's. And with NLTKs, we can find all the collocations for a given corpus very easy. For example, we can get United States, fellow citizens, federal government, and so on. Also, we learn how to write the loop functions and the conditions. And for example, we can use else if and the else to control the executions when if fails. For example, we iterate every word in the sentence once using loop functions. Then we check if this word is a lowercase. If not, then we go to the else if step to check if this word is a title case. If not, we go to the else step to print this word. Okay, this is probably everything we want to review from the last lectures, and please feel free to ask us any questions in the forums or contact us by emails. We will be very happy to help you all the time. Today's lecture we will still focus on how to use Python and NLTK to make test analysis, but the difference from last lecture is today we will learn how to write Pythons and NLTKs in a more sophisticated ways. For examples, in this lecture, we will learn how to write well-structured programs that you can reuse it anytime, and also it's very convenient for other people who you want to collaborate. And also we will know some common problems in Python, and we will learn how to avoid them. Now let's get started with functions and to see how to write functions in a more effective ways. The definition of function is very simple, where you have an input x and through the function f, where you can define a lot of calculations, and finally you can get the output you want. And functions provide an effective ways to package a lot of calculations, and you can reuse this piece of code. And for example, if you want to read something from several files, maybe you don't want to code a reading process many times for different files. Instead, you can create functions where a reading process is coded only once. Then you can reuse these functions to read something from different files. And also keep in mind the coding habits is very important. For example, please make sure you name the function and the variables more clearly, such that your codes will be more readable for yourself and for people that you want to collaborate with. And also you can always write comments for the functions and make the code become even more readable. Okay, and please notice that the comments are a type of docstrings, so you can basically print the comment of our particular functions and to tell readers what this function is doing. For example, you have functions named reader test files, then you can invoke help functions with a parameter of this function names, read the test files, then you can get the comments of these particular functions. Also, we can specify the parameters for particular functions. For example, if we want to repeat a message by number of times, then we can create a repeat function with two parameters, a message and the number of times you want to repeat. And in these examples, the message is bigrams. And notice that in Python, we cannot repeat bigrams by number of times. Instead, we have to first transfer these bigrams into a list. Then we can repeat this list by number of times. And in the last lectures, we know we can use joint functions to transfer a list of unigrams into a strings. Now we see we also can use joint function to transfer a list of bigrams or any type of n-grams into a string. Now let's look into variable scope. When we have functions, then we create many variables inside these functions. But these variables are only in local scope, which means these variables are only visible inside of these functions, and one cannot access these functions from the outside. And notice that the names of these local variables can be the same as the variables from the outside. When you create a particular variables, then the Python compilers will allocate an available address in memories to store values for that variables. For example, if you have a global variable I, which is assigned to a value of 3, then you can use the ID functions to print identities of these variables. And notice that we can treat identity of variables to to the address of the variables. So we can say with ID functions, we can get the address of a particular variables, and then we invoke functions with a parameter I as the input. Then according to the definition of this function on the left side, we can get the second address and the third address. And notice that the second address is equal to the first one, but the third address is different from the two. This is because the local variable I is assigned to a new address and with new values. Finally, we can check if the address of the variable I has changed after executing the functions. And now you can see the address. The final address is still equal to the first one, so you can see any modification to the local variables will have no impact to the global variable that you define outside of the functions. Let's see the other examples to check if two variables have the same values and address. First, we have two operators here. First, we have is operators, which returns true when two variables share the same address. And also we have the equal operators, which returns true when two variables have the same values, no matter whether or not their addresses are the same. And let's see the example below. So we have L1, L2, and both are a list of numbers whose values are the same. Then we print, if we print the value, if we print addresses of L1 and L2, we can see the addresses of them are different, and so L1 as L2 will return false because the addresses are different. However, the L1 and L1 equal L2 gets true because although their addresses are different, but they have the same values. Now we look into different examples if we assign two variables to the same values of numbers or strings instead of a list, then the addresses of them will be the same. For example, if we assign A and B to the same value of 5, then we print the address of A and B. Then we can find that the address of them are the same. And so SSB will return true, and A equal B returns true as well. And also, if we assign A and B to the same string of Pythons, and then the address, both address of values of them will be the same. And for more information, you can read the articles below for the details. Well, normally parameters need to be imported in the correct order that you defined for the functions, but you don't have to always stick to that orders as long as you specify the default values for the parameters, or you specify the values along with the name of the parameters. For example, you can only import one parameters, the number of times with a value of 3. Then the repeat functions will repeat the default message empty by 3 times. And also you can only input message, alias as parameters only. Then the repeat function will repeat the alias by 1 times. Please notice that we can specify the parameters in opposite orders to the order we defined in the functions. In this case, we still be able to get correct results as long as we specify the parameters by their names. And also we see here we can input and inbuilt Python functions as the parameters to the functions, to a particular functions. For example, here we can pass a length functions into the extract property function that we defined. As a result, we can get a list of length of every single words in the given sentence. Now we see another examples that we can pass new functions that we define to our particular functions. For example, here we create a last letter functions which obtain the last letter of every single word. Then we pass these functions into extract property functions. Then as a result, we can get a list of last letters of every single word in the given sentence. In other case, we see we don't have to create last letter functions explicitly because we can use lambda to do the same things, which doesn't require explicit function definitions. And also here's more case to show how to transfer from a normal function to a lambda functions. For example, we have pi and addition functions, and both of which has simple calculations, so we can make them into lambda functions, but be careful if we have functions that requires a lot of calculations. For example, many lines, you have to code many lines, then it's much more difficult to transform them to lambda function. Now let's see how to use Python to create sequences. We have learned two types of sequences, lists and strings. Usually we use list to store a sequence of words, while we use strings to store a sequence of characters. And now we will introduce a new type of sequence called the tuples. Here are the examples. We assigned two strings and one numbers separated by commas into a variable t's. We call this variable t as a tuples. And notice that the operation that we have learned before to operate strings and the list also can be used to operate tuples. For example, so we can get the position for a particular element in the tuples. Also, we can get subtuples by passing a range of indices as an input. Also, we can get the length of the tuple. And you can see here the data structures for the tuples and the list are very similar, but the one big difference between them is tuples. You cannot modify any element in a tuple, so tuple is immutable, while you can modify anything basically from anything in the Okay, now let's see the difference between tuples and the list. Here we have examples where we assign a and b to a list variable L and to a tuple variable T. In these examples, we see both data structure looks very similar, but one big difference is that tuples are immutable, which means you cannot modify any elements in the tuples. But you can do any modification you want for our list data structures. And also notice that in Python, you can use both data structure to store any element you want. For example, you can use them to store elements of different types, but we want to differ the usage of tuples from list in practice. So usually we prefer to use tuples to store elements of different types, while we want to use a list to store elements of the same type. Now let's see another examples where we have three inputs. For example, we have strings for the variable rows, and we have a list of words for the variable test, and also we have a tuples with two elements for the variable pairs. In the line force, we access to a particular elements in the inputs, and in one lines, then we can get the particular words and in tuple structures. And in the line 6, we access to the sublist of these inputs ranging from the last 3 tokens to the end, and also the results is in a tuple structures. And in the line 8, we see we can get the length of each input and in a tuple structure as well. And in addition, we see we can make some transformations between tuples and the list. For example, we can use tuple functions to transfer list to a tuples. Also, we can use a list function to the other way around. Now we were looking to how to access multiple sequences at the same time. For example, so we have a list of words and also a list of part of speech tags, and using zip functions, we can iterate every element in both lists at the same time. For example, in the results, and we can get the I and the noun as the first elements, and the term and verb as the second elements in the list, and so on and so forth. And please notice that the zip function is valid only in the case when two lists has the same length. Now let's see if we want to develop a machine learning model, so what we have to do in the first place. Here we give an examples where we load test corpus from the NPS chart dataset. Now suppose we want to develop classifiers which we use to label every word in the test corpus into different categories. For example, we want to check if a word is numbers or punctuations or real English or German word. To do so, we have to first split the test corpus into training and the test dataset. In these examples, we use 90% of words for trainings and 10% words left for the test. Now we can train the classifiers to learn the perfect decision boundaries for word classifications on the training dataset. After trainings, we can test the model, the classifier capacities on the test dataset. Now let's see another examples of combinations of tuples and the list. First, we transform strings into a list of words, and then we iterate every word there and to get the word itself and the number of characters. Then we use the sort functions to get a new list of words by designs in the ascending orders. And notice that the sort functions is looking at the values of first elements in the tuples, which means the words in the new list will be sorted by their word length. So if we transfer the new list of words back into strings, then we will see the results here where the words are sorted by the number of characters. Now we will see the summary about the usage of the following sequence types, where we see usually we prefer to use strings to store text-onlys, and usually we use a list to store elements of the same types, and we prefer to use tuples to store elements of different types. Now let's look into unique features in Python, which is called generator expressions. For example, we are dealing with a task which we aim to find maximum values from a list of lowercase words. In Python, we have two coding options, which are called generator expressions and list comprehensions. And for example, in the line 1, we can use what is called list comprehensions to get all the elements for a given list in the first place. Then we can call max functions to get the results. The problem of line 1 is in the extreme case, a list may have the infinite number of tokens, so probably it's not a good idea to get all the elements in the first place. Instead, when we look into the line 3, and then we can use what is called a generator expressions to get the iterators instead of all the elements for a given list. The advantage of these generator expressions is all the elements in a given list are accessible only in the case when needed. Python provides these generative expressions to make the running process in a more efficient ways. Please notice that from the mathematic and the time complexity views, generator expressions and the list comprehensions have no difference. Now we have known that we can use a list data structures to store a list of words. But if every single word has multiple properties, what data structures we can use to store both informations? Here we will introduce a new data structures in Python, which is called dictionaries. And first, let's review the list structures where we can use list to store a list of tokens like calling Ismails. Then we can access a particular word by its positions. Now, if we want to build word frequency tables where every word has one properties called word frequencies, what data structures we can use in Python? The goal is we want to access to a particular word frequencies by specifying the word. So basically, so we can create pairs pairs with key and values, where key is the word and the value is the word frequencies for every element or every entries in the dictionaries. And to do so, we can use the dictionary data structures in Python. First, we have to create an empty dictionaries in the line 1, and then as in the line 4, we assign the first values colorless, and we can assign the first key colorless and first value adjectives. Then we will get the first elements with a pair of key and values, colorless and adjectives. And also we can repeat these operations many times for different elements or entries in the dictionaries, so we can get the key idea and its values now, and also get the key sleep, and the noun and the values verb, and so on and so forth. Finally, we can build tables where we have every word and its properties of part of speech text. Finally, so we can access to a particular part of speech text by specifying the key. For example, so we can get the noun, and by specifying the key ideas. Now we will see we have different ways to access the entries in the dictionaries. For example, so we can get all the keys by calling the keys functions, and also we can get all the values in the dictionaries by calling the value functions, and also we can get every entries, both key and values, by calling the items. Functions. Also, we can iterate every items or entries in the dictionaries by using looping functions. Then we get the results as the following. Now let's see another use case for dictionary data structures where we wanna create tables to store words and their pronunciations. For example, here we have a word fire, and in the American English, there are two choices of pronunciations written in different phonetic alphabet. As you can see here, we have one choice of pronunciations in a list and another pronunciation in the second list. And with NLT case, we can just call the functions in NLT case to get the tables for words and their pronunciations for a particular corpus, and then we can iterate every entries in the dictionaries in a subdictionaries by passing a range of indices. Now, as a result, we can get 3 different items with the word as key and the pronunciations as the values. And now, if we want to access to particular pronunciations by the searching words, first thing we can do is just iterate every word and pronunciations in the dictionaries. Then we check if the word is equal to the search word. Then if so, we just get the results, just get the pronunciations we want. But this algorithms runs O(n) times, where n is the number of entries in the dictionaries, and instead we have more efficient ways to find pronunciations, where we can just access to a particular pronunciations by passing the searching word as the parameters. Then we can get the results, and this ways the algorithms only runs O(1) times. So this is very efficient ways to get the elements to get the pronunciations you want. Also, we can find all the words that end in a list of syllables. For example, first we create a list of syllables, and then we iterate every word and pronunciations in the dictionaries. Then we check if the last 4 pronunciations for every word is equal to the list of syllables that we specified. Then if so, we will get the word. As a result, we will find words like Atlantic, audiotonics, avionics, and beanics. And even though the spellings of these words are pretty different, but the pronunciations of the last 4 characters are very much the same. Now let's see some other examples for using Python's for using dictionary data structures in Python. For examples, we can use Python. We can use dictionaries to build document index tables where every element, every entries in the dictionaries is made by keys and values, where keys are the word itself and the values are list of pages. Where every word is found in the articles. And also we can use dictionary structures to build a thesaurus tables where every key in the entries is meant for the word sense and every value in the entry is meant for the list of synonyms. Now let's see some other operations that we can use for creating dictionaries. For examples, we want to use dictionaries to build word frequency tables where some of words probably have 0 frequencies. To do so, we can take the advantage of default dictionaries, and by assigning default values 0 frequency here to every single word. And also we see that we still can create the new entries in the frequency tables by mapping the word like frequency by mapping the word like colorless to its frequency with a value of 4. And also we notice that if we have a word that like the word ideas that are not found in the frequency tables, then the frequency will be assigned to the default values, zeros. And let's see the other examples in the following. So we see that we can set default values to not only to an integer number, but also to a strings. For example, we want to use dictionaries to create part of speech tagging tables, where we can still use the default dictionaries to map default tag noun to every single word. And like the previous examples, we can create new entries by mapping the word colorless to adjective, and also for some other words that are not found in the dictionaries, and the default tag nouns will be assigned. Now we will see other use case for default dictionaries. For example, we have a task that we want to extract all the frequent words in the text corpus, but assigned infrequent words to a special token UNK. To do so, we have, of course, first to load the text corpus, then we use frequent distribution functions to extract the vocabularies. Then we can call the most common functions to get a thousand of frequent words. And from the dictionaries, then we can create mapping dictionaries with the goal that we want to map frequent words to the word itself, and map infrequent words to a special token UNKs. So to do so, we will first putting all the frequent words into the mapping dictionaries. Then we iterate every single word in the text corpus. Then we check if this word is found in the mapping dictionaries. If so, we will print the word itself. If we cannot find it in the dictionaries, then we will print the default tokens UNKs defined in the dictionary. Now let's see how do we incrementally update elements in dictionaries. For examples, we want to get counts for every single part of speech text in a given corpus. To do so, we will load all the words and the tags in the corpus. Then we create a count dictionaries, which we want to map a serial count to every single part of speech tags in the corpus. And then we make iterations over all the words and the tags. Then if we find the tag is in the text corpus, then we will update the counters. After that, we can access to our particular counters by their tags. Let's see another examples for updating dictionaries. Suppose we want to use a dictionaries to create anagrams for a particular word, which means we want to rearrange all the characters in a particular word so as to produce a number of new words that share the same characters in different orders. To do so, first we have to load all the words from NLTK corpus. Then we will create an anagrams dictionaries where we can map a default values. Here is an empty list of anagrams to every single word. After that, we just make iterations over every single word. Then we use sorted functions to rearrange the characters, all the characters in the ascending orders for every single word. And then we can make the entries in the anagram dictionaries by mapping the sorted word to a list of anagrams. In NLTKs, we can implement the above algorithms in a more convenient ways. Of course, we have to make iterations over all the words in the first place. Then we can use what is called index functions to merge all the anagrams together when these anagrams share the same characters. Now let's look into brief overviews of NLTKs where we can make our own calculations to update default dictionaries. But we can make this much more simple. For instance, we can just call the frequent distribution functions and to get the word frequency for every single word in one line code. Also, we can call index functions to merge all the words, to merge all the values that are indicating to the same key. And also, let's see how to invert our dictionaries. For example, so we have a dictionaries where keys are words and the values are the tags. So if we want to access all the words for a particular tag, it's could be a little difficult. So the solution for this problem is to invert the dictionaries, which means we want to reverse keys and the values. So as you can see here in the code, and where we iterate every key and the values from the dictionaries, then we put the values as the key while put the key as the values. Then we can access to all the words by specifying a particular tag. Okay, now let's look into the summaries of dictionaries. Just like the list all the operations that we can do for dictionaries, data structures. For example, so we can create an empty dictionaries, and also we can assign a key to a particular dictionary up to a particular key in the dictionaries, and also we can get all the keys from the dictionaries by calling the keys function or call the list functions, and then we can sort all the elements, sort all the keys in the dictionaries, and also we can check if a particular keys is in the dictionaries, and also we can make iterations over all the keys in the dictionaries, and of course we can access to all the values in the dictionaries and create dictionaries from a list of key value pairs, and also add all items from D2 dictionary to the D1 dictionaries, and also we can create a default dictionaries where the dictionary where the default value is 0. Also, we can add all items from one dictionary to the others, and also we can create dictionaries where we set default values to 0. Now we will review what we have learned in today's lectures. Generally, we learned structured programmings, and for instance, we learned how to use and define functions in a more sophisticated ways. Then we learned how to use the lambdas to make very simple calculations without the need for defining functions, and also we know how to make condition logics and combine condition logics with the functions, and also we learned the sequences, and for example we know the list and the tuple data structures, and also we deviate between the two. Finally, we learned how to use dictionaries and to map multiple properties to every single word. For example, so we can use dictionaries to build word frequency tables where we map every single word where we map the word frequencies to every single word. Well, if you want to collaborate with other people, in addition to structural programming, it's also good to follow the coding style guidelines and to learn, for example, what is the best ways to name variables and functions to make it more readable. And I would say the best way to teach yourself is start to practice. So I would suggest you to find some small NLP project and start coding right away. And here there's a lot of useful resources, and for codings, for example, so you can learn how to make your code understandable and readable, and you have some Python editors, and also they have some commonly used Python libraries for plotting functions, visualizing graphs, and also for matrix calculations. Okay, that's probably everything for today's. About the preparation for next week, I would recommend you to review what you have learned from the previous lectures, and also check the solutions for the practice class, and also read the chapters from 4 to 4.6 on the NLTK website. Finally, make sure you have a solid understanding of the basics in Python. If you have any questions, please feel free to write down in the forums or contact us by emails. Okay, thank you very much for coming today. See you next week.